Okay, hey there, guys. Today we're going to talk about the fundamental theorem of calculus. I'm pretty happy actually to reach this part now because I can actually start proving to you that derivatives of a function are actually correct because of the fundamental theorem of calculus. Now, this is going to introduce this cool little symbol called the integral. Now, I'll write to you what the fundamental theorem of calculus says. It says that the integral of a to the b of f of x f prime of x dx is equal to f of b minus f of a. Now, this is important because this actually, this actually combines a lot of ideas here. So the idea here is that, right, this is important because this is kind of what relates the derivative to its original function. Because, right, if you have a derivative of a function, obviously there's a relationship between that derivative and its father function, so obviously there must be some sort of way you can go backwards to go from the derivative back to the father function. So basically this is the representation of it. Now the idea here is that a to b are limits of integration, okay? So these are basically the limits that the function is going to be evaluated at when we actually find that function. And the way we find this function, because we have f prime of x, to find f of x, when we integrate it, we actually go to here. So let me show you an example, okay? So let's say I had a curve, okay? Let's say we'll start with a linear guy. So let's say I have a linear guy, okay? A linear guy, and our f of x is equal to 5x, okay? So we want to figure out what the area under this curve is, right? And if we integrate, well, actually, okay, let me back up here. First, let's take the derivative of this, right? And the derivative of this is equal to 5, okay? So if we were to graph that derivative, right, okay? So if we were to graph this derivative, it would basically just be this line at y equals 5. So that would basically be it. So let's say we wanted, we wanted to evaluate this derivative, okay? So the integral, let's say from 2 to 5 of 5 dx. And what does that equal? Okay, so, right, basically when you're integrating, and I'll do methods of integration, I'm just introducing the fundamental theorem of calculus because this is an important idea. Basically, okay, we're at x equals 2 down here and x equals 5, okay? So let's draw this, okay? So what the fundamental theorem says, that if I find the area under this curve with the integral, that is going to be equivalent to the function, our f of x, which is, we know it's 5x, so, and we have our limits here, so if f of b, so we know that it has to be 25 minus 10, which is equal to 15. So we know that the area under this curve has to be 15. Well, what's unique about the shape we have here, okay? And we just graphed the derivative, right? So this is 3 units long, and this is 5 units high. And what do we know about area of a square? It's base times height. So this area is 15. So we just proved that the area under the derivative is equal to the function evaluated at the upper limit of integration minus the lower limit of integration. Now, why is this important? Well, if you have some sort of rate of change, okay, let's say, you know, you have found some sort of rate of change and you want to write a function for it because, right, you want to examine this rate of change at different times. Well, if you might not know what the function is, but if you have a rate of change and you have limits that are actually, you know, important to that specific model, then you can actually evaluate that integral and figure out what the function would have to be, and plus you can figure out what the answer to that integral would be with the limits. So basically, from the fundamental theorem, I know that this might be confusing, but this is basically just the introduction of the integral. And I'll write it one more time. Basically, the fundamental theorem says the integral from a to b, this is an integral, this little s thing, and f prime of x, the integrand, this is what we call the integrand. The integrand will always be a rate of change. Like, yeah, it will always be a rate of change. So, and see, we can go back up the ladder. So, if you integrate this, you'll go back to f of x, okay? Let me write this out first, and then I'll show you. So that's equal to f of b minus f of a. So if I was like, if I had like something like the integral of a to b of f prime x equals f prime b minus f prime a. So what did we just do? We just learned that from a derivative we can use the integral to go back up. So we can go from the second derivative back to a function that will be the first derivative, and if we know a function for the first derivative, then we can actually go back again and go to an original function that is just not a derivative, it's actually the function. Now, based on, you know, the circumstances of your derivative and what it means, your, you know, going up the ladder will mean different things based on the subject matter, basically. So yeah, that's a fundamental theorem of calculus. I hope you enjoy it. This is a very important part. This is what's going to take us into integration techniques and such. So yeah, I hope you enjoy it, and see you next time.